Let's take a look at the next example in 9.1. Here we're looking at the relationship between age and the vocabulary of children. The x variable will be the age, that's going to be the independent variable. We expect the vocabulary size to be dependent on age, so the dependent variable is vocabulary size, that's going to be the y. And the first thing we're asked to do, other than determine the independent and dependent variable, is they ask us to do a scatter plot of these two to determine the type of relationship that might exist linearly between the two. So we're going to go ahead and put this data into our calculator. Again, you would go to Stat, Edit. The x variable should go in the first list, so we have 1, 2, 3, 4, 5. That's going to go down the first column, L1. The y variable, which is the vocabulary size, is going to go down the L2 variable. And now, once I have everything set, what I want to do is I want to create the scatter plot. Again, from before, everybody should already have the scatter plot turned on. We did that for the first problem in this chapter. So it should still be on, so you shouldn't have to do that again. I want to go ahead and I want to hit graph. I hit graph, and once again, nothing's showing up. So what's going on this time? Well, I had just moved on from the previous problem and just entered this brand new data set. So what's happening is this window here was a window that was set up nice and neat for our last data set where the values were very different from this. So every time you kind of input a new data set, when you go to look at the scatter plot, you always have to go back through the process of doing the zoom stat so we can create a brand new window that fits this particular data. So again, that's going to be under the zoom menu, which is right here. We want to scroll down to the option for zoom stat. Should be choice 9. Go ahead, hit enter. And when we do that, this is kind of what we see. As we might have perhaps anticipated in the beginning, the older someone gets, the more new words they learn. So we would expect that age and vocabulary should be positively linearly correlated. Furthermore, it looks to be awfully strong. I see a couple points that deviate a little bit. So visually speaking, it doesn't look like it's going to be a perfect linear relationship, perfect positive linear relationship, but it does look to be awfully strong. The question then becomes, well, how strong is it? And that's where our R value is going to come into play. So let's go ahead and compute the R value here. To do that, we go Stat, go over to Calculate. Remember, it's choice 4. As long as we have that diagnostic tool turned on as we did earlier, you don't have to do that again. By now computing the linear regression, that will give us the R value. So the R value here is 0.996. Again, that's awfully close to 1, so that's a very strong positive linear correlation. Let's take a look at the last example in 9.1. They ask us to compare the movie budgets and how much the movie grossed in the box office. Across the X is the budget of the movie in terms of millions of dollars. And the gross we're going to let be the Y variable. So the independent variable is the budget, that's X. The dependent variable is how much it made at the box office. The gross, that's going to be the Y value. We want to determine how these variables are going to be related in terms of linear correlation. Let's go ahead and plug them in. I first want to clear off all of this data. So I'm going to clear L1, move the cursor up, clear L2, and let's go ahead and enter it. Our first X value from the table was 300, 258, 250, 210, 232, 230, 225, 207. Directly across, and this is very important, you have to match them up. Every X has to get paired with its Y. So the budget for the first movie was 300. Its gross was 961. So that's going to be the first element in the next set. 891, 937, 836, 391, 576, 419, and then 551. they don't ask us to do this, but let's just go ahead and graph it anyway. So I'm going to graph. Need to rezoom it, so I'm going to do zoom stat, just so we can kind of get a visual inspection before we compute our R value. If I do a zoom stat, it's definitely not a strong relationship, we wouldn't say. As we kind of move from left to right, the general pattern is it does look to be going up somewhat, but they are slightly scattered. So we might be able to make the case for perhaps some type of positive relationship here, albeit it's probably not going to be much of a strong one. To confirm this, and the ultimate test is what is the R value. We go to stat, let's go over to calculate, linear regression, hit enter, and sure enough we get an R value of about 0.604. 0.604 is not very strong at all, so we would refer to this as a weak positive correlation. The benchmarks themselves for what separates, strong from weak to no correlation is kind of vague, and oftentimes it depends upon the discipline, whether you're looking at things like the natural sciences versus the social sciences. For us, we will tend to take the viewpoint that anything, 0.9 or higher in absolute value will be strong. Of course, if it has a R value of -1 or +1, those are perfect linear relationships. Anything roughly between, I would say, 0.3 to 0.8 or less than 0.9 will be weak. And if you start to get into that 0.3 or less in absolute value, we'll consider those to be no linear relationship for our class.